All right, in this video, you are going to learn how to solve equations by using a process called completing the square. So we're going to use everything that you've learned from the first two videos. So for example, factoring perfect square trinomials and then solving an equation by taking the square root of both sides. And also figuring out what number we need to add to a partial quadratic in order to turn it into a perfect square trinomial. So we use this method when we have a situation like this. If we look at our problem right here, x squared minus 10x plus 7, if we tried to factor this, we would look at our terms, right? We see that x squared, no coefficients, so we know that we're going to have x for both of ours. Our last sign is positive, but our middle is negative, so we know both of these are going to be minus. Now, if we look at the factors of 7, we've got 1 and 7, and that's it. So if we tried to plug in 7 and 1 here, we would get, minus 7 times x, so minus 7x, and then minus 1 times x, minus 8x. We would end up getting x squared minus 8x plus 7. This is not the correct factor for this polynomial. Now, normally, you're just saying this is not factorable, or we can't solve this. That's not the case. We can solve these equations, but there's a little bit of modification that we have to do in order to turn this into something that we can solve. So the method for doing this is, first of all, we want to rearrange our equation so all we have are our a and b terms on our left-hand side. Okay, so we want to get rid of this constant. Okay, so when you first get an equation that's set up like this, you always want to move your constant. If it's not factorable, you want to move your constant to the right-hand side. So we're going to subtract 7 from both sides. So minus 7 and then minus 7 on our right-hand side. So what we'll be left with is x squared minus 10x. And then I'm going to leave some space here because what we want to do is we're actually going to use the method that we've just practiced on. We want to turn our polynomial into a perfect square so that we can solve it by taking the square root of both sides. So I'm leaving some room right here because we're going to end up adding some number to this equation. Now, we can't just add a value to one side of our equation and leave the other side the same. That will then change the equality of our equation, and it won't be true anymore. So what we need to do is we need to first figure out what value we want to add that's going to turn this into a perfect square trinomial. So we go through the same process. Here we see that b is negative 10. So then we take b over 2, which b over 2 is just negative 10 over 2, so it's negative 5. And then we want to go ahead and we want to square that. So we get b over 2 squared is 25. Now, you always want to remember what b over 2 was because that's going to help you when it comes to factoring this. But what we've just figured out is that 25 is the number that we need to add to our trinomial, to our polynomial, to make it a perfect square. Now, we can't add 25 to one side without doing the same to the other. So what we actually have to do here is add this value to both sides of the equation. Okay, so now look what we've done. We've first, by moving our constant over, we're left with part of a trinomial, and we are now able to figure out what number to add to it to make it a perfect square. So you can't forget this on the right-hand side. That's a common mistake that people make. Now what we can do is we know how to factor this. So remember, all you do is you take x, and then whatever your b over 2 value was, that's what you put into your binomial. And then we just write that as a binomial squared. And then we have to go ahead here. Don't forget to do this. We have negative 7 plus 25. So we get that that's equal to 18. So now look what we've done. We've taken an equation that we didn't know how to factor or wasn't factorable, and by rearranging our constant and then adding this value to turn it into a perfect square, we've now turned this into an equation that we can solve by taking the square root of both sides. So now we take the square root of both sides, the square root and the exponent cancel, and we're left with x minus 5 equals, don't forget plus or minus, don't forget that you're missing half your answer if you do, plus or minus square root of 18. Now we just isolate x. So here we go ahead and we add 5 to both sides, and plus or minus, we know that square root of 18, we can factor out the perfect square factors of 18. So 18 is just equal to 2 times 9, and the square root of 9 is 3. So this just turns into 3 root 2. And here are your answers for this problem. You get x equals 5 plus or minus 3 root 2. Now, you can leave your answer written like this, or you can write it out as 5 plus 3 root 2 and 5 minus 3 root 2. Okay, either of those are acceptable. Let's look at one more example just to make sure that I want to show you one thing that's a little different. What you hopefully what you've noticed is that in all of these problems, we've all been able to factor these, but we haven't had a coefficient in front of our x squared. It's always just been x squared by itself. If you have a problem that has an a value greater than 1, so if x squared has a coefficient, before you can start subtracting your constant and going through the process, you have to divide everything in your equation by this a value to get rid of it. We want to turn our trinomial into a perfect square binomial that just has x plus or minus a value. So, and this method of adding b divided by 2 squared only works if x squared is by itself without a coefficient. So, what we want to do in this example is when you have a problem that you're going to solve by completing the square and you have an a value, the first thing you have to do is divide both sides of your equation by your a value. Okay? Now I'm writing it here on the right side, even though 0 divided by 3 is going to be 0. You may have, if you have a number over here, don't forget to divide it by a as well. Okay? So let's go ahead and go through the steps quickly so you can see this. So the first thing we want to do is divide both sides by a. So when we divide both sides by 3, we end up getting x squared, because 3x squared divided by 3 is x squared. 12x goes into 4x, and 15 goes into 5. You have to divide every term by your a value. Okay, now we've got an equation that we can go ahead and start completing the square. Again, you'll see x squared plus 4x plus 5, this is not factorable as it's written. Okay, the only factors here are 5 and 1. 5 plus 1 would be 6, not 4. So we have to go through the process of completing the square to work this out. So what we want to do first is move our coefficient over. So we subtract 5 from both sides. Now we've got it just in the form x squared plus bx. So just our first two terms. Now we want to go ahead and we take b over 2, which is 2, and then square it. So we want to add 4 to both sides. Okay, now we write it on the left and the right. Now we go ahead and we can factor our left-hand side. Turns into x plus 2 squared. Negative 5 plus 4 is just negative 1. Now we can take the square root of both sides. We get x plus 2 equals plus or minus root negative 1. and then we subtract 2 from both sides, and we get -2 plus or minus root -1. And remember, root -1 is just equal to I. And this is fine too. You're going to have answers that have imaginary numbers in them, so complex answers. That's completely fine too. Don't get stumped. You didn't do anything wrong. That's a perfectly acceptable answer. Okay, so now that you've seen completing the square, what I want you guys to do is go ahead and solve each equation here by completing the square. Don't worry about 11 or 12. Just do 7 through 10. So I repeat, you do not need to do 11 or 12. Just solve 7 through 10 and go ahead and enter your answers in now.